and hopefully I'm live. I'm gonna do that thing where I wait to make sure that it actually shows up. I see the preview in my software. I see stream is being received from my dashboard, and I don't see anything on YouTube yet, so that's a little... Oh, there we go, and now I see something on YouTube. Good morning, everybody. Welcome to day 5 of Dashboarding with Notebooks. It's the very last day, can you believe? Oh, and just something I wanted to bring up really quick. I did not know that this was happening until literally today, but apparently the data school is also doing dashboarding week this week, and they've got some assignments, and they actually talk about Tableau. So this is on their blog. So if you're interested in things like Tableau, I think they talk about Power BI and stuff like that. You can check that out. I don't tend to work in that particular sort of like framework. I actually don't think I've ever used Power BI before. So yeah, that's something else for you guys to check out if you're interested. Today we are going to be doing testing and validation. And the reason that I'm doing this is because it's good to do. This is kind of like the eat your vegetables week, eat your vegetables day of the week. It's important to do sometimes. And one of the long-running arguments I've had with a variety of software engineers over the years is that testing is less... not necessarily less important, but less sort of universal in data science in our day-to-day, and you don't always need to test everything, especially if you're developing a model, you're sort of like doing feature selection, you're developing new metrics, things like that. You don't really need to build tests to make sure that your code is working if you're still, really changing what the code is doing and it's not entirely clear what the test should be doing. And it's just, data science is just much more exploratory than software engineering as a field. Like, we know how to build web apps good, right? That's something that's like knowledge that's in the world, and if you follow the best practices, it'll be fine. We don't necessarily know going into a project on like image labeling what framework is going to work, what architecture is going to work. Like, there's some ideas, there's like general guidelines that will help you out, but you don't know necessarily what the exact output of your code is going to be until you finish building the model. So it's not something you usually... this is like straight up my opinion and me being opinionated. It's something that I don't think you really need to worry about until you are starting to put things into production, or doing something like this, like a dashboard where you know what the code is, it's pretty much done, it's ready to go, and you just want to make sure it's running correctly. Kamal says he didn't get the email, so the link for this I think I posted in the chat further up. Our email service just like decides not to send emails to users it's decided aren't active, quote unquote, and I can't change who it's decided is active or not. And it's frustrating, and I wish that they wouldn't do that, but they did. So if you didn't get the email and it's not in your spam and it's not in your promotions folder, that's probably why, and I'm sorry, and I wish I could fix it. Ben says, I'm an electrical engineer who's worked as a software developer, lots of experimental stuff. Yeah. So you do want to do testing and validation if you're working on a project where you have some code that's going to be run repeatedly. So if it's something you're only ever going to run once, like, I don't think it's that important to build tests. That's just me. If it's going to be run without supervision, so something like a notebook that you are always going to be running and looking at it with your eyes, if there's an error, you're going to see it with your eyes. Especially if it's something like, I don't know, regression, and you're doing your good diagnostic plotting and you're checking to make sure that your modeling assumptions aren't being validated. In that case, I mean, you're looking at it. That's the testing, is you and your expert knowledge and your ability to interpret the model. And if it's running repeatedly on its own, and if a mistake happens, bad things will occur. An example would be if this is a dashboard that you're sending to your boss and you are suggesting to them, they're going to use the dashboard to decide whether or not to open new stores. And if your dashboard makes a mistake and maybe drops all of the data for a specific city because somebody started putting it in with a typo, and suggests that nothing is being sold in that city, and actually a lot of things are being sold in that city, and they decide not to open a store or close a store that's being very successful, that would be an example of a bad thing that would happen if you didn't include testing and validation. So these are things that are sort of done. And I've done 2 versions of today's notebook. One is in Python, and that should be the link you got in the email, if you got the email, which it sounds like some people didn't. And that is the Python version, and I've also done an R version. So I'm going to go through the notebooks and then do a little bit of live coding to sort of show you how this would work on a different data set and not my, you know, little minimal working examples that I have here. So testing and validation are different things apparently, and if you call data validation testing, people get grumpy about it. Here I am only going to be validating data in CSV files. So validating data means that your model is built on certain assumptions about your data that you're taking in. So you're assuming, let's say, that column with the count of stores that are currently open has integers in it and not floats. So if your code will break if those assumptions are violated, you want to check them. And a lot of the validation packages that are out there, for Python in particular, are really focused on JSON files. And there are a lot of tutorials out about there. So I'm only going to talk about CSV because I don't know about you guys, but I think I use CSVs more than JSON in just my day-to-day. So the Cerberus package is probably the most popular one for validating JSON files in Python. And the CSV validator package is the, at least I've done a lot of sort of research, and this is the package that I like best for validating CSVs in Python. If you guys know of others, feel free to shout them out. And it is not actually installed in kernels by default. I actually need to make a pull request on the Docker image to ask for it to be, because I think it's really helpful. So you're going to need to install it, and you can install things in kernels either using, in the editor, there's a little sidebar that has an installation, walkthrough, and you can also use the Jupyter magics to run pip, and you can just do magic pip install CSV validator. If you use the sys executable as well, this is going to be more robust if you're in your local environment, because just installing pip won't necessarily install it in your local environment, won't necessarily install it in a directory that's available for the notebook that you're working in. So this is just sort of best practice. But it will also work on Kaggle if you just do pip install. So here I have, let's actually scroll down and I will show you an example of a CSV that I have. So this is a CSV that has 6 columns in it. It has the key, the date, the unit name, the unit sold, the store, and then notes. And I want to, when I get in a new CSV, make sure that it looks like this, and that the fields that I'm relying on for my analysis and my graphing and my dashboard and whatever I'm doing are actually there and are in the format that I expect them to be in. So to do that, we are going to create a validator. So we're going to import everything from CSV validator, so we don't have to do CSV validator dot blah blah blah. These are the field names that I am checking to make sure are actually there. You will note that in the file here, there's this column notes that is empty in the first row, has big day in the second row, and is empty in the third row. And I'm not actually checking it here because I'm assuming that this is for a dashboard where I'm not using that notes column. So I might look at it as a human, but I'm not actually doing anything with it programmatically. So if it changes or if it's not there, it's not going to break my code. So I'm checking to make sure that these these columns are there and that they are called this. What was that? I heard like a clunk. Well, hopefully it was nothing. Oh, I think it was my neighbors. And then we create a validator with those field names. And then we're going to add some checks. So each of these will be added to our validator that we created, so we don't need to run each check separately. They'll all be run at the same time when we use the validator to check our data. I've put each argument on a separate line just to make it a little bit easier to read, but you don't have to. You can put them on the same line. That's fine. And we have a couple of... Excuse me. I'm so sneezy in the morning this week. And we have a couple of things that we're looking for. So the first thing that we're looking for is in the key field, we want to make sure that we have an integer. And this should be a function that takes in a single argument and it'll raise an error if it doesn't work. So you can use int, you can use other float, you can use, I'm trying to remember data types in Python. I know there's more than one. And then this is the name of the exception that will be raised if the key isn't an int in any of the rows. And then our helpful error message that we're gonna send back if we find that this is a mistake. And so I've added a couple. So we're going to check that the date is actually a date time and that it's in the format year, month, day. We're checking that units sold is an integer, and we're checking that the stores are either store 1 or store 2. So this is in a thank you, people saying grüß. So we're checking that it's in this list. I don't think that's actually a list of stores. And if any of these things are violated, we're going to get our error code and then we're going to get our helpful message about what's wrong. So I'm doing a little example here, and rather than reading in a CSV, I'm actually hard coding the CSV in the notebook as a string. And that's just so that it's a little bit more self-contained. I can sort of copy and paste this code and use it other places, or import the code if it's in a package, and just make sure that it's doing the thing that I expect it to do. So I am reading in this string as string input, and then I am reading it in as a CSV using the CSV module, which we imported. And then I am validating this test CSV. So I'm making sure that all of these fields are here, and I'm making sure that all of my checks are passing, and I get an empty array out. So that's good. That's what we want. That means that there weren't any exceptions. And here's an example of a CSV that is going to have some exceptions. So you'll notice that 200 written out is not actually an integer. Store 3 is not one of store 1 or store 2. This date is month, day, year rather than year, month, day. And this key is a float rather than an integer. So we're going to read this in and we're going to try validating it as well. And you can see we get a lot of exceptions because there's a lot of problems with this data set. So I can see that the number of units sold is not an integer, it's 200 written out. We can see that the key is an integer here, it's 2.5. We can see that this date is invalid, so it's not parsing correctly with the format that we gave it. And we can see that store 3, the store name, is not recognized. Viraj says, hi Rachel, is today the last? Yes, this is the last day of the dashboarding event. I am actually going to be doing a live stream. Most Fridays I do live coding at 4 p.m. Pacific, and this week I am doing dashboarding related live coding, so there is a little bit more dashboard related content, but this is the last stream for the event. So if we had this in a notebook, we could print out this output, and we wouldn't even need to show this cell, and we would see nothing if all of our checks passed, and we would see a bunch of error messages if there was a problem with the data that we got in, because the data that we're using here is being updated, and maybe somebody made an error when they were entering the data, or maybe the the database itself has been updated and they did something like change one of the names of one of the fields. So Ben says, when this output says row, does it exclude blank lines or comment lines or unreadable? And the output says row. 4443, row 3, column 1. Let's see. I don't know. That is a good question. That would be something I would look in the CSV validator documentation to double check. WL says, are the links for these sessions posted on YouTube or Kaggle? Yes, that's a good question. So in each of the notebooks, and I'm going to go back today and make sure that all of the days are in all of the notebooks. At the very top of the notebook, there are links to the notebooks for each day, and then the last link is going to be the link to the live stream, and that should be persistent, she said. Yeah, so that should be persistent. So you can go back and watch the live streams. And there is also on the Kaggle YouTube channel a playlist. So if we go to Kaggle, whoop, and we go to here, and then we go to playlists, dashboarding with scheduled notebooks has all of the live streams in it, including this one. Good question. Where were we? Right, so that is the validation process using the CSV validator package in Python. In R, so I'm going to do each language back and forth. Oh, live coding on Fridays. Yes, those are also in a playlist. So they're on the same YouTube channel, and then they are in the live coding playlist. So yes. Good question. And then I also do on Wednesdays a reading group where I just sit and read a paper aloud. I promise it's more interesting than it sounds. Little sip of tea. Okay, so the process in R is a little bit different because we're using a different package, and I can see that I actually didn't remove this information that talks about Python from the R notebook, so I'm gonna have to do that later. But the code is correct and should all run fine, and I just missed some of the markdown. Sorry about that. And we're going to be using the validate package in R, which I really, really like. I think the syntax is very, I find it very intuitive and very elegant. So just like with the CSV validator package, we're going to create a validator, and it's just going to have all of our tests in it. So Daniel says linguistics or coding? Coding paper. Yeah, so it's usually some sort of machine learning paper. Right now we're reading the Attention is All You Need paper, Viswali 2017, I think, which is about transformers. Yeah, and we're about halfway through, and then I got sick, so it's been a couple weeks, but I think this Wednesday I should do it. WL says, can the validation package just flag errors, dump the results in an output file, skip the bad record, and continue processing the data file? That seems likely. I haven't actually done that process, but yeah, I think it should be able to. Good question. Okay, so we are making a validator for our data, and we have data with pretty much the same assumptions. I've just added one extra thing. So we are making sure that the key, so this is going to be the name of the field in the data frame that we're looking at, and I don't need to specify that this is I don't need to specify anything about the data format. This should work with most R objects. I haven't tested it extensively with things like nested lists, but Should. And then I have each test has a name that I associate with it. So I'm just calling the two that test date and store, and then the one that makes sure that the key is numeric, key numeric. So it's checking that the key column is numeric, and that includes floats and integers and any numeric type of data in R. And then key unique makes sure that the number of duplicated keys is exactly equal to 0. So you can put anything as a test here that's going to return a Boolean, either a single Boolean or a string of Booleans. For the date, we are making sure that when we parse date as a date time using the lubridate package and the same format as the other notebook, we don't get any NAs returned. And then for store, we make sure that the each row of store is in this this vector of store 1 and store 2. So this does basically the same thing as scroll, all of this code, except it doesn't give us as verbose of error messages, and it doesn't check explicitly and separately the names of the field. Rachael says, if it's not numeric, can we make them by as numeric? So you could, but the problem with that is if you have something like a string that's actually text and not a number, you're going to get weird errors. And then if you try and treat it like a number down the line, that's not going to work for you. So this is just sort of telling you what's wrong. It's not necessarily fixing what's wrong. Yeah, but good question. And I'm actually going to blow my nose really quick. I'll be right back. All right, sorry about that. Much better. Yes, so, oh, so you can see that there is some namespace overlap here. And then, just like with our WL says, the validate package is essentially a wrapper around all the other R packages. I wouldn't necessarily say it's a wrapper, but it does interact well with other packages. Oh, and Ben answered as well. Yeah, that's it's just changing the data is a little bit more complex. So this is just gonna give us a little error message if things aren't the way we think that they are. A little bit of tea. Yeah. Okay, so now that we've created our validator that has a number of tests, we are going to try it with something. And even though the highlighting, the code highlighting isn't actually correct here, this is valid R. So it's the exact same text-based CSV as we had in Python, but we don't need to do the string IO nonsense in R. We can just read it in as a CSV. And then we're going to confront to check our test data with the validator V that we made earlier. We can see that we have 4 confrontations, so we look at all the rows, and there are no failures, warnings, or errors. And then if we try again with a data frame that does have some errors in it, so this has more or less the same errors as the last one, except I made the one of the keys not unique, which if you're using a database is going to cause you lots of problems. A little sip of tea. We will get a lot of errors. So we can see that we have 3 failures and 1 warning. But it doesn't actually tell us what the failures and warnings are when we just run the function. To do that, to get more information on specifically what problems there were, we can plot a summary. So if you've worked with regression in R at all, this is fairly similar, where you're just running the regression and then you look at the summary of the regression and then you look at a plot of the regression. And in the summary, we can see that all the keys are numeric, so one item and it passed. The keys are not unique. There was one item. It's the vector of the data frame, the column of the data frame that has a key in it, which is a vector. And it's testing the whole vector, and it fails because they're not unique. Date, 2 of them succeed and 1 of them fails. And then store, 2 of them succeed and 1 of them fails. And then our bar plot shows us the same information but visually. And if you are colorblind, just so you know, this bar is red, this bar is green, and there's also a yellow option for if it's NA. None of these are NA. And for here in the store and the data and the date, columns, we can see that we have 1 failure in each and then 2 successes. And again, this is red and this is green. And there's a line right here. And this is not excellent data visualization because, again, red-green color blindness is very common, but it is sort of available to you, and you can tweak the options if you're interested. So that's data validation in R and Python. And again, this is just going to give you error messages. If something is up, it's not necessarily going to do, logging or, actually fix what the problems are. It just lets you know there are problems. So validation is for data and testing is for code. And let's hop back to Python. What we are not doing here is testing visualizations. So the way that you would test visualization, I asked a bunch of engineers about this, is that you would do a pixel by, I should clarify, I asked a bunch of mobile engineers and front-end engineers about this, is you do a pixel by pixel comparison of what you expect the visualization to look like and what it actually looks like. And that seems like nonsense. I think that that's just too much work, so I guess just look at your visualizations and make sure they look good with your eyes. And if the data that you are putting in is the way that you expect and your data pre-processing is doing what you expect it to do, y'all can design beautiful graphs. I've seen a bunch of them, and I'm not worried about your ability to write robust code there. But someplace where things can go really wrong is in our data processing. So what we're going to be doing here to test our data processing is black box testing. So just like where I made some little examples here. Question from WL. So in general, you think validation is important, but testing not so much. I think they're both good. You want to make sure that the data you're getting in is good and the things that you're doing to it are good. But I don't think you need to test your graphs. I think that that's kind of a waste of time. And I'm sure somewhere some software engineers are like, no, graph testing is deeply important. When I say graph, I mean visualization, not networks. If you're relying on a specific network, architecture for some sort of graph-based modeling, then yes, you probably would want to test that if it was very important and you were running the code a lot and people weren't looking at it while you were running it. So we're not testing the graphs, but we are testing the pre-processing. And so the big thing that can go wrong here is a library that you're relying on can get updated in a way that breaks your pipeline, or you might have missed something in your data validation that then causes you to have errors. So maybe you're using a library that can't handle non-ASCII characters and your data validation says, yes, absolutely, this is a text string. But then when you try to run it through your pre-processing pipeline, you run into trouble. So I've actually borrowed from Dinara's notebook here some of her some of her pre-processing. If I scroll down, we can scroll up, we can check it out. So I'm borrowing this pre-processing she's doing for the Burrow data, and I am putting that in a function. Ben says, I would say data validation is more important because you might have bad data that isn't invalid and you wouldn't notice it. For example, a broken sensor giving an output of 0 constantly. Yeah, that is a good point. And we've done pretty simple data validation here, but you can get much fancier. You can build all sorts of custom checks with CSV validate. little bit more tea. So I've created a function here that does some processing of the data and then returns processed data. You can see that it relies on having columns called borough, number of persons injured, and number of persons killed. Generally, it's not a great idea to rely on these unless you're doing something like data validation to make sure that you actually do have these columns going into your I would rather you use column names than column indexes, let me say that. But referring to specific parts of a data frame means that if the data frame changes and these field names changes, your code is going to break. Yeah. Blah, blah, blah. Ben says, I've written my own so many times. I'm glad to know CSV validator. Yeah, it's a really nice package. And WL says, so validation almost sounds like a form of automated periodic data wrangling. Yes, except it doesn't change the data. It just looks at it. And it's like, are the assumptions that you've told me to make correct here, given, you know, the data that I've been shown. But yeah, it's a good first step. Right, so we have some code here that counts the number of persons injured and the number of persons killed per borough. Yeah, borough. That's what they're called in New York. Given some raw data and removing all of the nulls. So I am going to create two raw data frames here. So this is based on the data set, which is why it looks a little bit funky. And this is a input data that is like the data set that we are actually running this function on. And then here is the output data that we would expect given this input data and this function. So if you're doing test-driven development, you can actually do your sort of expected output data first, given your specific input data, and then write the function to make that. I think for this type of very small data processing, that's a little bit overkill, but people really like that process, so if that's you, feel free to do that. And then we are going to use this function built into pandas, testing.assert_frame_equal, and give it the correct output and also the test CSV that we've written here, this test input, with our pre-processing applied to it, and we want to make sure that they are exactly the same. And they are, so we get no output. Ben says, fun story, old versions of Toyota navigation systems often couldn't find McDonald's restaurants because the databases had various spellings, including some even Mickey D's. Oh, that's interesting. I didn't know that. Right, so we get no output because these frames are exactly equal. So if you're doing something like this and you just collapse the code cell and you don't collapse the output, you won't see anything in your notebook unless something goes wrong. And here we have a, what is this called? Another CSV that should not be the CSV that we get out given our input. So you see that the expected output is 1 injured, 0 killed. Here we have 0 injured, 0 killed. So here the math was wrong. And we see here in the last row with Queens, I've put B. So this is not something, again, that you should get out of math, at least in base 10. And when we assert that this data frame with errors is the same as our data frame that's been pre-processed, we get a bunch of errors. And you can see that there's a little bit of a description of what the errors are, but this would be very noticeable in a notebook that there's something wrong with this call asserting that our expected output and our data that we've run our pre-processing function on are the same. Yeah, so that's the so we're doing sort of the same thing that we were with validation. So we're checking a specific input and output. But the thing that we are testing here is this function. We're making sure that this function is doing what we actually think it's doing, and it's giving us the output that we expect given input that is like the input that we are expecting it to get. And in R, we can do the same thing. So I have borrowed this little bit of function, and I've messed with it a little bit from this dashboard loading, which I think we might have talked about yesterday. I think I mentioned this. This is the Flex dashboard I mentioned yesterday by Rachael. So I've just borrowed some of this pre-processing script. And in case you didn't know, the code that is published publicly in Kaggle in kernels is all licensed under Apache 2.0. So reuse with attribution is absolutely fine. WL says, it seems to me this testing could mistake an outlier for an error. Yeah. So the thing that we are actually testing is that the data frame that we get when we run our function on this is exactly the same as this data frame that we've built by hand. So unless there's an outlier in this data frame, so the big problem here is that you can make a mistake, right? Like, because I'm making these data frames by hand, I can make a data frame that has certain input, and then the data frame that I'm making here might not be the one that I would actually want given that input. So definitely, because you're making things by hand, that's an area for error. But you'll be able to tell that that there are errors, because when you run your function, when you test it with the correct data, you're not going to get no errors out. You're going to get specific errors, and you can sort of figure out where those are coming from. So it should be able to handle outliers, because we're not actually giving it new data. We are giving it always the same set of input data and output data to make sure that this function is always doing the same thing. Does that make sense? It's Me says, how to approach documentation of any library for using any of its features or module to look for it, which are not common to use, which is a student working on a new library. Oh, yeah, that's a good question. So for our libraries, which tend to be much more centralized, the thing that I would look for would be vignettes. So vignette. And I would look for, if there's a specific library you've heard about and you want to check it out, vignettes are small code examples that sort of walk you through how to use the library. And that is an R specific thing. But that's what I would start with, rather than reading the CRAN documentation that's like, here's the list of all the functions. For Python, the ecosystem is a lot more diverse. I like to start with blog posts if there are one. Failing that, read the docs. I think CSV validator was on read the docs. Is a Python. Nope, it's not. A lot of Python libraries are on read the docs, which is a place for hosting documentation for packages, and we'll have really nice example there. This one, I think the documentation is mostly on GitHub. Yeah, it's for R, I would search for a vignette. For Python, it's a little bit more grab bag. J. Harris says, is this testing and validation part of my notebook code that gets run every time the notebook is committed or run on GCP by another platform? Yeah, so I'd recommend putting it in your notebook. And you can even do, so we're not actually, no, that's not true. The Pandas testing module is actually running tests. With R, we're not actually doing any tests. You could be using test that. If you wanted to run tests, we're just sort of printing some output if something is up, which I think is fine for dashboards, because dashboards are for looking at by humans. And if you are looking at it as a human and you're like, there's some error there, I should probably contact the dashboard maintainer. That's fine. For something like this, blah, 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 blah. What is this? The data validation in R, you can check to make sure that you have like 0 failures and 0 errors. And if you do not print anything out, and then if you do print it out, and then if you have your code collapsed but your output not collapsed, you will only see information on the validation if there is an actual error. If that makes sense. I hope that answers your question, Jay. All right, so we have a function. Oh my God. Sorry, it's been a long week. It's been a fun week. I've really enjoyed it, but also just a lot of work. So we have a function here that takes in this data frame. It changes the date to the week of, you know, it bundles all of the dates by weeks, and then it counts the number of incidents per bureau in each week, and then it renames, because count always outputs a column n. I'm renaming this n column numbers, so it's a little bit more transparent. And then I'm doing the same thing. I've got an example data frame that we might be reading in, and then output data, which is the correct data for so what we would expect this function to give when run on this data. And we're just going to compare that these two are equal, and we get some errors. Have I made a mistake? It looks like I've made a mistake. So we shouldn't get any errors here, and I need to figure out why we've got some errors. So the test has worked and told me that there is a difference between these two data frames. Row x but not y, 1. Row and y but not x, 3. So there is... Okay, let's... I'm going to finish talking about this, and I'm going to get into this and figure out why this test is throwing an error, because I think that is interesting live coding. Number. Okay, so I was thinking it might be that the columns had different names, but they shouldn't. Yeah, so let me spend some time working on that. What all equal does, all underscore equal, I should say, not all, I think it's all equals, no spaces, no underscore, is in base R. This is from dplyr. And it looks and it makes sure that every cell of two data frames is the same. And I'm using this convert function to coerce similar data types to be the same. So basically, if there are a float and an integer, integers are very rare in R for historical reasons, it will convert them both and be like, yes, they're both numeric. These are basically the same, and I'm going to compare them as numbers. It says, what if there's a module in Pandas documentation which isn't common to use, but I don't know how to approach the documentation? Should I read the whole documentation? Ooh, I love documentation. Pandas is a big package. I wouldn't read all of Pandas documentation unless you had the time for it. I honestly like looking for sample code. So if there's a specific, let's see, so if there's a specific Pandas testing. If there's a specific, nope, that wasn't. If there's a specific, sorry, I was going to try and see if I could see if anyone had a Kaggle kernel about it. If there's a specific thing I know I'm looking for, I will look for sample code for that usually, just to see how other people are using it. So you can try on Kaggle. Usually I use the Google search for Kaggle. The other thing you can do is you can look on testing.pd.testing.assert equals, I think it was. I'm just going to try that. So you can also search all of GitHub, search on GitHub and find code that uses it, and then look at that sample code and figuring out how they're doing it. Yeah, it's kind of hard. You can also ask on Stack Overflow. If it's a machine learning related, you can ask on the Kaggle forums. People are usually pretty good. Kaggle Noobs, the Slack channel, is also another place to ask for help. People are generally pretty good there as well. So yeah. Jay Kumar says, on the cloud, do we have an option to run kernels as such instead of creating a new version every time? Not sure if there's any such functionality via the Kaggle API. There is not. Yeah, no, sorry. It's always going to create a new version, and that is, you know, a choice that we have made as a company, so that you can look back at your old code and see what it looked like before. And it's really good for reproducibility. So if you're working on, you know, some research project, you can look and see what you did, you know, 2 days ago, and then compare it to what you're doing now. So it's yeah, you're always gonna get a new version. Sorry. Yuri says, in this case, what is being tested is a pipeline to generate the dashboard. Yes, that is a good question. Correct. WL says, the R universe seems more organized than the Python universe. Is that a fair assessment? I don't know about organized. It's more centralized, right? Because R as a language is for one thing. It is for statistics and data analysis, and that's it. So everything in R pretty much serves that purpose, and it means that the community is a little bit more tightly knit. The Python community is a lot more dispersed because Python's for a lot of things, right? Python's for web development. It's for, you know, building apps. It's for data pipelines. It's for, you know, a wide variety of things in addition to data analysis and machine learning. So yes, but it's more of a social organization than, you know, our people are better at planning or anything like that. And it's just more centralized because there's fewer use cases. But I like R. Yeah, so we can see that when we compare this CSV that is incorrect, we do get some errors, which is good. We should get that. We should not get errors when we compare the CSV that doesn't have any errors in it. So I'm going to spend some time working on that now. Yeah, and then just on your own, I want you guys to go through and validate some data and also do some testing. And I am actually going to fork this notebook and figure out what's wrong with it. WL says, apples and oranges. Yeah, absolutely. And it's me says, it was nice to get answers from you. Oh, thank you. I'm glad I could help. A lot of it, I don't know, especially when you're new, it's just like, you don't know where to ask for help. Like, you don't know what a good question is. Like, even like knowing the right things to Google, it seems like such a simple thing and people are like, oh, just Google it. But if you don't know that you're looking for a CSV validator, then it's going to take you a really long time to find a CSV validator, right? All right, let's see. So our validation worked good. And our, this did not. So it says there's a parsing failure. Let's break this apart. So I think it is Alt-Shift-Dash, Control-Shift-Dash to split a cell. Yeah, okay, so Control-Shift-Dash to split a cell at your marker. Okay, so there's a parsing failure here. Oh, okay, I see. So the parsing failure is actually in the test data. What if I put it in double quotes? Will that magically fix it for some reason? I did test this yesterday and it was working, but all right. So in row 3, 7 columns, 8 columns, literal. 1, 2, 3. So it's this row that has an issue. So that looks right to me. That does look like the right number of columns. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Am I counting wrong? Borough is 1, zip code is 2, latitude is 3, longitude is 4, number of persons killed is 5, number of persons injured is 6, date is 7. 7 columns. Borough, zip code, latitude, longitude, killed, injured, date. Okay, that one was right. Borough, zip code, latitude, longitude, injured, killed, injured, date. People say in Bronx. Yes, yes, excellent. There is an extra comma. So now when we run it, okay, no parsing errors, and we can see that it's all equal. You guys are lifesavers. Thank you. All right, let's pop this sucker back up in here and do that. Excellent. And I'm actually gonna copy and paste. I think I have edit access on, I think this account has edit access on the main version. So let me go back and fix that now. It's me says, is Kaggle fast for running deep learning models than Google Colab? Edit notebook. Yes, I do have edit access. So you have more or less access to the same computational resources. Like it's the same GPU backend for both of them, I believe. It's 1080. Or at least it was. I don't know about Colab today. I haven't checked in a little bit. Yeah, I mean they're more or less they're comparable. It is up to you what your personal preference is between the two. I think for me, the thing that I like better about Kaggle than Colab is I think that file management is a little bit simpler because in Colab you need to upload things to your Google Drive, and the process is just, I find, a little bit less user-friendly. I believe you do have more runtime on Colab rather than you have on Kaggle. I want to say 12 hours on Colab, 6 hours on Kaggle. Don't quote me on that. I think so. Yeah. It's me says, I tried to run my model on Kaggle, but it was trouble for me to upload image data and save it here. For image data, I recommend uploading a zipped folder. I don't know if you tried that. Yeah, and I mean, very large data sets are going to be trouble in general. But if it's working for you on Colab, feel free to keep using Colab. I'm not going to be like, you have to use Kaggle. Remember. All right. So now our test should actually run. Oh, and I believe, let me make sure that this is actually, I think it's been publicly announced, but I want to double check so I'm not just like saying things that you guys can't actually go and do, because I think that would be very frustrating. It might be in datasets. Sorry, there's something exciting that I think is public. And I think Megan would have posted it. So let's see what she's done recently. And Dee says, Kaggle and Data Studio are now talking. Yes, there is a connector with Data Studio. So if you are a Data Studio person, you can get that set up. Sort by latest post. Yes, it is available. Okay, so another thing that might help you with datasets is that you can now add datasets from GitHub repositories or remote URLs. So if you have a dataset that's hosted on GitHub or I don't know, some server that your university is running or something, it's a little bit easier to upload into Kaggle. So this is still in beta, but I'm very excited about it because there's a lot of cool data on GitHub that should be easier to use on Kaggle now. So that's exciting. Ben says, I tend to prefer Python because the TPU, which is faster than a GPU. Yes, for some things, TPUs are faster. Ben says, TPU is married to TensorFlow, which has a Python API but not R. It is not available to the public yet, but Rachael would know better than I. Oh, there actually is a, actually, I think it might go through Python, but there is a TensorFlow interface for R that's maintained by RStudio through Keras. So you can use TensorFlow in R. I don't know about R and TPUs. I've never actually tried. I haven't played around with TPUs because I'm not doing a bunch of really big projects. Ryan says we can direct download basically. Yep, more or less. I mean, it's still going to create a data set on Kaggle like any other data set, but yeah, you don't have to like download it to your computer and then upload it. So it'll create a data set like this. Yeah, it is exciting. Oh, it's still running. Let's see if the update has actually been published. Going back to the dataset, still running. Okay, so once it's done running, we should be able to see that our tests passed when I said that they passed, which is great. Ben says, really can't use with R today, I learned. Thank you. Oh, good. I'm glad you learned that. It's not good that you can't use R on TPUs. I would like to use R on TPUs, so. I think R makes sense as a language to do that because under the hood in R, everything is a vector, which is why for loops are so slow and vectorization is so much faster. So it would make sense for something like a TPU, but I don't know that it's a priority for the people who are working on it. Yeah. So I was going to do more live coding, but I might actually save a little bit of juice for this evening because I'm going to be doing a whole hour of live coding and I want to make sure I'm not just like staring at the screen going like blah because I'm so tired. WL has another validation question. Validation is really not for large data sets since the validation itself could take a fair amount of processing time, yes? Yeah, that's a good question. I would say you would still want to do it with large data sets if it was something important, but it would be yeah, your optimization of your functions would probably be a little bit more important. So something like the functions that you're using here, isNumeric is pretty fast. I think any duplicated is fairly fast. I mean, it's going to be a little bit slower by just like the nature of the question that you're asking. In is fairly fast. I think the parsing date time might be a bit of a bottleneck if you had, 100,000 dates. Well, 100,000 should be fine. If you had a couple million dates, parse date time should be a bit of a bottleneck. I would definitely recommend if you're doing any sort of date parsing with validation, making sure that you're not inferring the date format because that can really slow it down. I want to say, at least in Python, it's like 6 times slower to infer the date format than to actually provide it. So it's good to say the format that you're looking for. But yeah, you might want to spend a little bit of time of validation, a little bit of time on optimization. D says, you've been brilliant. Aw, thank you so much. That's very sweet. Ben says, this is useful to know because I've been strongly promoting Python over R and Java at my employer, and now I should maybe calm down. Python's great. Like, I don't want to dunk on Python, but I also like R. Both are good. Ryan says, are you still working on the Kaggle data later or moving on to something else? Yeah, I think I'm going to be working more on the, for the live coding today, I'm going to continue working on the forum topic summarization generator thing, and the code for that actually doesn't run right now because I hard coded into it a assumption about a matrix dimension that the data, when it's different, doesn't make a matrix of the same dimension. So I'm gonna have to fix that and then make something sort of interesting and cool. I might work with what is it, Xtable? I might turn it into an R Markdown document and work with I think it's Xtable. There's a really nice library for making pretty tables in R. Blah, blah, blah. Ryu says, anyone know if I can host a Shiny app on Google Colab? I don't think they support R. So, no. I think. They might, but I feel like they would have mentioned to me if they were getting into R. Jules says, in a job context, how are dashboards used? Just emailing the notebooks to the people interested, or the notebook is like notes for the data scientist to help present their analysis to others. So usually so for me, at any given time, my team's working on a large number of projects, and we will present, at meetings, and we might present figures there. But if my manager or people that let's say I'm testing something for somebody, and I've got like a dashboard that talks about the test results, then that might be something that they might want to just look at whenever. And that's why a dashboard is nice rather than emailing them, because they know it's going to be, oh my gosh, sorry, I got a notification and it was very loud. That way they're going to know that it is current at the time the dashboard was run. WL says, on day 3, Pam says, asked about your plan to teach some advanced ML stuff in R for future Kaggle competitions. What I heard was yes, thank you in advance. I'll think about it. Yeah, I think some deep learning in R would be nice. There's not as many resources out there as I would like, so maybe. Ben says, thank you for the course. How long will the recorded video links be valid? I must leave. Enjoy Seattle. The links will be valid as long as Kaggle has a YouTube channel. Like, we're not planning to take them down or anything, so hopefully they should be good pretty much forever. It's me says, does making an accurate model be good enough to put on a resume, or should I deploy it and then put it on a resume while applying for an internship or a job as a side project? I would, if you have a project that you have trained and then deployed, especially if you've done something like created an API for it, or you have a nice website that people can go and look at, I would strongly recommend doing that over just building a model. Yeah, I've got, somewhere I've got slides on putting together portfolios. I think they're... I think it's /talks. Yeah, so I'd recommend, the more you can produce something that is like what someone would use in a business setting, the more compelling that's going to be in a resume. Blah, 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 blah. Here we go. Here are the slides. So it's rctapman.com/docs/data science portfolios, and there's the link to the slides. Yeah. All right, so it's 10 and I've got an appointment at 10:30 that I need to get to, so I'm gonna call it a day for now. Thanks so much for joining me this week, guys. I'm sorry that there were some, a couple of rough edges. Thank you for bearing with me. I appreciate it. And if you're gonna be back later today, I will see you then. And if not, thanks for joining me. I really appreciate it. I hope you found this useful. You learned something. I really enjoyed putting it together. And happy solstice. Enjoy your longest / shortest day of the year, depending on your hemisphere. So yeah. WSL's Kaggle and MOOCs are really changing the world. I hope so. I hope so for the better. Yeah, thank you for joining me, and hopefully I'll see you guys around, either on Kaggle or YouTube, and I will talk to you then. Bye-bye.